Okay, so this is, I'm going to go over the worksheet with you so that when you take your quiz, some of you already took your quiz, but didn't do well, and those of you that didn't do your quiz, because you are a little confused, maybe this will help you, right? And if you did do this worksheet, then, get it out so you can check your answers with mine. Make sure that you're doing it correctly. Okay? All right, so the first one is not a percent yield problem. It doesn't ask you for the percent yield. It's actually asking you to solve just a regular stoichiometry problem, which means you're solving for a theoretical yield. Okay, so you balance the equation, and then they say you're decomposing 36 grams of water. How many grams of the hydrogen should you get? So you're starting with 36 grams of water. Change that to moles using the molar mass. Put it in there, and you need to find hydrogen. So we can see it's a 1-to-1 ratio, so the same number of moles, and we're going to just change that into grams. Okay, so number one's very simple. They're probably trying to work you into solving a percent yield. So this was just a theoretical yield problem. And actually number two is also just a theoretical yield problem. So you balance the equation. They say you want to produce 581 grams of sodium chloride. That's this stuff right here. Change that into moles. Okay, that's where it goes. And they're asking for grams of sodium. So that's this. And once again, it's a 1-to-1 ratio, so the same number of moles. So now we're just going to take that, change it into grams using the molar mass. Okay, so the answer is 228 grams of sodium needed. Okay, number three. Okay, this one is I think it's a limiting reaction problem. So you have, I forget how many grams of oxygen. No, it's just a regular stoichiometry mass-to-mass problem. So you have 180 grams of glucose, and glucose is this one. So you change that into moles. Turns out to be just 1 mole. And they want to know how many grams of oxygen you will have to breathe. So we're finding this, and we can see it's a 6-to-1 ratio. So we're going to take that and multiply by 6, which you can do in your head, 6 moles of O2, and then we're going to change it to grams using the molar mass for oxygen. Okay, so that's 1, 2, and 3. Number 4. Now we're getting, look at there, percent yield. What is a percent yield? Okay. So we have 4.61 grams of zinc reacting with hydrochloric acid. So there's my zinc. My hydrochloric acid produces zinc chloride and hydrogen gas. How much zinc chloride should you get? Okay, so we're going to solve for that first, because the next part says, suppose you actually recovered this. So they're asking you to solve for that, and then they're giving you that. So what does that mean? Well, this is your actual yield. So we're going to solve for our theoretical yield first. So we're going to take our 4.61 grams of zinc, use the molar mass of zinc to find the moles. Okay, and then we're going to find zinc chloride moles. It's a 1-to-1 ratio, so it's the same number of moles. Then we're going to take the molar mass of zinc chloride to convert it into grams. So this right here is your theoretical yield. Okay, and then so that's the answer to the first part of the question. The second part is if you actually recovered this, 8.56 grams, then what is your percent yield? So we're going to do our formula, actual divided by theoretical times 100, and we get 89.1 for number 4. All right, number 5. Determine the mass of carbon dioxide that should be produced in the reaction between 3.74 grams of carbon and excess O2. What is the percent yield if 11.34 grams of CO2 is recovered? So they give you this product, the amount, but that's your actual. What you need to do to find percent is get the theoretical. So we're going to need to solve for that. So we take our 3.74 grams of carbon, divide by 12.01, that's the molar mass of carbon, and we get 0.311 moles of carbon. Okay, and this is already balanced the way it is. So it's the same number of moles of CO2, and then we convert it using molar mass to get our theoretical yield of CO2. And we can place that in the bottom of the fraction here in our formula, actual over theoretical. Actual was given. Okay, actual divided by theoretical times 100, and there's our answer. It's an 82.8% yield. Okay, and then the very last one. Is it the last one? No, sorry, there's more. Okay, number 6. So you have this reaction. We have 4.28 grams of oxygen. Potassium oxide is formed. What mass would you expect to form? So that's your theoretical yield. So we're going to change our grams of oxygen to moles of oxygen. That goes there. And then we got to find how much product we can make from that. It's a 2-to-1 ratio. So we multiply that by 2. We can do that in our head. And then we change that into grams using the molar mass of that. And we get 25.2 grams. That's our theoretical yield. That goes on the bottom. And in a percent yield problem, they always give you the actual yield, right? 17.36 grams of K2O is actually produced. So we take that, put it on the top, and put it in our formula, and we get 68.8% yield. Okay, so here's number 7. Determine the mass of carbon dioxide one would expect to form. Carbon dioxide right here. And percent yield for the reaction between, this is methane, CH4, and 11.6 grams of O2 if 5.38 grams of carbon dioxide gas is produced along with some water. So this is what is actually produced. Okay, they want you to find the percent yield. So you got to figure out the theoretical yield of this. All right, so we take our 11.6 grams of O2, change it into moles. There it goes. We use our molar mass. This is half of that, right? So 0.1. So we take this, divide by 2, and we get that. And then we're going to take that, change CO2, use molar mass of CO2, and this is our theoretical yield. Okay, and then we actual over theoretical. Remember, the actual is always given in the problem. And we get 67.4%. Okay, and then the last one, number 8. 15.8 grams of ammonia. We take that, change it into this is grams. We change it into moles. There we go. Okay, and then the percent, let's see, the mass of water actually formed is that. So we're trying to find the theoretical amount of water that's going to be formed. So then we do the mole ratio 6:4, right? So we take our 0.927, 6:4 ratio, and that gives us 1.391 moles of water, and we convert that to grams. This is our theoretical yield. That goes on the bottom. And the actual yield, which is what was given, divided by theoretical, gives you the percent yield. Okay, so if I went fast, just, do it, like slow down the speed of the video, and you can follow along or press pause. But really try to understand how to do these, because your next assignment, you're going to get a mixture of problems, and you'll need to be able to recognize what type of problem it is, and then be able to solve it. Okay, so good luck, everybody. See you later.